Today we're going to go through Explore using a case study, so it's going to be easier maybe for you to have an idea of how we can use Explore. The case study we're going to use is a case study of recovery borders, so we can see the piece of equipment here. We can find that piece of equipment in the pulp and paper processes. In the craft process. So we can, in this piece of equipment, we are burning the black liquor to recover chemicals, and at the same time we're producing steam for the process. In this case study, we're gonna analyze one sensor that had a special behavior, and we're gonna try to find out what happened for the SO2 to rise quickly like that. So at first we're gonna import data. To do that, we're gonna connect to a database. So this database is on SQLite on my computer here. So we're gonna import the data, and as it is in that type of database, we're gonna have just few variables. If the information of the variables separate than the information of I will, instead of those, I would take maybe those two here. No. Thought I had it. Okay. This one, variable description, and after we're gonna go get the information to recover the data here. So as you can see in the data table, we have only 3 columns. One for the ID of the sample. Here it's the date, the ID of the variable, and the value. And we're going to assign those fields in Explorer to identify the variable, the date, and the value. So here we're recovering only the information about the variable and the connection to the database. We don't recover the data right away, because if we're connected to a real database, we don't want to import the whole thing just by connecting to the database. But there's one variable that is not present in my database that I would like to import, and that variable is in an Excel spreadsheet. So I'm gonna go get it here, import it, and since it's from file, I'm gonna import the data right away. And here, confirmation that is done. So we're ready to create the analysis, in which we can do with the little plus here, or there, or new analysis. And we're going to name the analysis. And here, as you can see, we don't have any data yet, except for this one, and this one automatically did set up the dates here to recover the other the rest of the data. So we can download them here. And if we were connected to a real database, it would be the raw data that we would have. So even if they're not synchronized, it's not a problem. Explorer will synchronize them and prepare the dataset as it is required. So you can choose to create an average with the data, or you can, if you prefer, use the closest to the time step that you're using. And here our dataset is every 10 minutes, so we're going to keep it at every 10 minutes here. So we can start the analysis. And here we're ready to already clean the data. So here we can see we have an idea already of what we would like to keep or not. And you can clean easily just by selecting what you want to remove. And once the selection is done, you have access to those little tools at the bottom. And one of them is to remove points, remove observations. And it's already clean. And as you can see, we have the operation that is added in the operation tree here, and we can rename it to be able to identify it later, and we can even open it to change some parameters. When we did that cleaning, we didn't clean only for this variable, we did clean for the rest of the dataset as well. So the other variable have been cleaned, because if those data were not good for this sensor, they were probably not good for the rest. It's not the case for every sensor, but in this case it was the case. So we can go see our variable that we are interested in, the SO2, and to be able to follow that group, we're going to create the group. So we can select the observations here, and once we have selected the observation, we can create the group. Oh, that color is maybe not the best. We're gonna change the color. So we can decide to show or unshow the group. And then we can continue the analysis. So as you can see, since we made a group, we have statistics for that group here. We have the distribution, and we could have done also, we can go through the whole set of variable one by one. We can also create a scatter plot here, and instead of that, could be interesting to use the primary air with the black liquor flow. And here we see that we could have maybe clean it like that, because that is not normal operation. Oh, and we have that one too. So here, once we've done the selection, we can clean, and that is black liquor and air. So, and we can come back like that too. You can also create your the sheet the way you would like to build it. So you have a generate sheet here where you have several tools. You can use those icons, or you can also make that appear and select what you want to add on your generic sheet. So a place to put comments and to leave a trace of the steps you have done. You can select the variable you are interested into, in this case the SO2, and you have the correlation here, so we can select the SO2 in this case, and we can remove the SO2 from the variables here because we already know that we're perfectly correlated. So we would know which one has a better correlation or not. So here we have several of them with negative correlation and several with positive correlation. We can also check the correlation matrix. So in this case, you can see, so the dark number are strong correlations. So either positive correlation in red, even obviously the variable with itself is a perfectly strong correlation at 1, and the others in blue are negative correlation. So you can double click to see the correlation here. This one is a little bit special, and we're going to analyze it a little bit later. So I'll just remove that one. So if we want to analyze this group, a good tool to do that is the PCA. So which will bring me here at the top, and where we have the model to create the PCA. But just before creating the PCA, I'm going to show you a little bit the tools that we have here. So we can split to create branches in our operation tree. So if we want to create different type of pre-processing, we can do it in splitting the tree. We have different tools for cleaning the dataset. We have filters to smooth the signals. We have a tool to replace missing values and invert the dataset. So if we take the PCA model here, which is the second one, I can select all the variable. I won't select the teams because it's not required for the analysis here. So here, so we're going to create a standard sheet to analyze the PCA, where we have the accuracy of the model, we have the loadings of a PCA, we have the scores, the t-square, the SPE, and we have the contribution of the group that is already calculated because we already created the group that is appearing here. Oh, I should have named my group as well here. So we already see with that tool that the SO2 among the rest of the data is special. And with the contribution chart, we can analyze it a little bit further. And on this chart, that is using the components of the principal components to show the difference or the contribution to a variable of a variable for that group being different of the rest of the other observations. So here at the right we have the SO2, that is higher than usual, and that is expected because that's the group we have selected. And on the opposite side, on the far left, we have here a variable related to the superheater. And we can see here that this variable is actually lower, has a lower temperature than usual. And we can see that also for other variables. We have here a superheater T4, superheater T3, and on the other side we have the pressure air at the second level. And we can see here that during that period the pressure has risen during that period to reach a high level at the end, even if there was a little bit higher level for a certain period of time. We are still at a very high level compared to the normal operation. So now that we have created our model, we can, and we did analyze what was happening here, we can actually clean it a little bit more to keep only suitable values. And we can just remove that part that is an unusual operation. And if I want to include it in my PCA, I can just have to replace that operation. T superheater. And now that my PCA is recalculated, I don't see the values of that operation because they have been removed, but I can apply my model to a step before doing that operation to see how my model would detect this abnormal operation. And we can see that the t-square would have detected really quickly as an abnormal operation, and the contribution would have spotted the problematic variables quite quickly. So we can also create other kind of models like PLS, neural network. We can do clustering, we can do lag analysis, create new variables. So there's a bunch of tools that can be used and explored. And there's also we also plan a way to let people add their custom algorithms. So we're gonna save that, and we're gonna go in the designer, which is the second part of the suite. And then in the designer, we're gonna use our PCA here to create a detection tool. So if we would have had many models, they would have all appeared here. And even if they were in different analysis. So in this view, we can remove the grid line here. We can implement a new image of the boiler. So we can have the piece of equipment that we're working on. We can add the value of the SO2. So we're building here a kind of dashboard monitoring that can be used after to monitor online not only the SO2 but the behavior of the whole uh, piece of equipment, which is here the recovery boiler. We can add charts, and here the SO2. We can add the T-square that we're going to work on. And so up to now we have created something that is visual, but we can change. We didn't create any detection yet. What we're gonna do is, after create the alarms, the detection based on the model, the indicator here, and we're gonna set a value for detection. So the detection is separate from the UI, so we can eventually create something that is standalone that would push the alarm in the user system without having to open the screen here. And here we're going to create, set the refresh rate at a lower. So did we create everything? Are we set up? Yes. So we're gonna save that. And then we're gonna go in the monitoring itself. Just gonna refresh to find our monitoring here. And we are going to open it. And since the connection is already done in Explorer, we're already connected to the system, and we're online in few minutes. We already have the detection, and we can actually analyze the alarm already and see what is happening with our piece of equipment. So we have here something that seems to be special with that variable, the oxygen in the chimney, and we see that we have a flat line at 25.5. Obviously that's not a normal oxygen level, but it was the oxygen level that we had at that moment. So the sensor wasn't operational yet, but it was already logged in the system. And we can go see actually the historical data. You can go see the historical data of the oxygen. Oops, it's a little bit. Let's go with more data, so we can see the flat line, and now we have really better values here. We can also see historical data for multiple variables. whoops, that was the alarm, sorry. And we can select those variables here. We can select, as an example, we're going to select all the flow meters here and get data. Oh, should have put every second. So you can see your data fairly quickly, and you can use multiple axes if you prefer, if it's easier when you have really a wide range, wide ranges, it can be helpful to do that as well. So as you've seen, we can perform that kind of analysis and go online in very quickly, and we think that can be really helpful to have something to detect abnormal operation of a piece of equipment, like a recovery boiler or any kind of piece of equipment that is really important in a process. So if you have any question, you can post it on the channel, or you can contact us as well. Thank you.